Now, what are the different problems transformation in computer? It has been divided mainly into three parts. One is called as a problem. The second one is called as an arithmetic language. And the third one is called as instruction set architecture. Now let us consider first one. What do you mean by a problem and how problem is getting saved, or how the problem that is getting saved is being getting to a stage where it is also getting solved. Now let us consider the case where, again we'll consider the same example of ATM. You landed up to the ATM, you had performed the task, the machine, and where you were interacting with the machine. And the machine was listening to your instruction and it was able to process or give you the desired output and result. That was the problem. Now, what do you understand by algorithm? Algorithm is the set of instruction step by step which is required to be fed into the computer system so that the computer can perform the instructions that are being given and act accordingly. The third one is instruction set. Now, when you have decided that this is my algorithm, this is my flow chart, now what you do after your algorithm is prepared, after your flow chart is prepared, now you start giving the instructions to the computer. The instructions are mainly the software. What are the different software languages you will be using to convert your algorithm into the software language? That is called as instruction set of an architecture or a computer. Now, let us look at one case, software design. Choose algorithm and the data structure. First of all, what do you understand by software design? Or what do you understand by a design? The design is the physical look in front of the end user who will be using it physically to get his or her needs satisfied. Now, the software design is also the same. When you are designing a particular software, you mainly consider what the user wants, how the user will use it. For example, let us consider the recent case of WhatsApp. When you consider WhatsApp design, the design is very, very simple. It is not complex. Now, suppose that if the design was complex, the ratio of the end user will it be high or low? If your software design is complex, the end user will be less. If your software design is simple, the use of end users will be very, very high. Then comes to programming. What sort of software language you are going to use, whether it is Java, whether it is .NET, whether it is COBOL, Visual Basic, C, C++, and so on. Now, first of all, let us understand what do you mean by interpreting, or the second word of interpreting is compiling. We all are aware that when we are writing our set of instructions, we are giving the instructions to the computer in the form of English. But the challenge is the computer understands English language or machine language. Computer understands only the binary language, which is called as the language of zeros and one. Now, compiling and interpreting helps to convert the instructions that have been given to the computer into the form of machine instructions. Then you have processor design. Now, the processors can be designed according to the instruction set architecture, or we can choose structure to implement, or we can choose a structure to implement ISA, that is Instruction Set Architecture. Logic or circuit design. When you say logic and circuit design, it will be considering the different sort of gates, that may be AND gate, NOT gate, OR gate, which are being compelled together and low circuit to implement at a lower cost and to give you the desired output and result. Process engineering and fabrication. Now here you need to develop and manufacture low level components. When you are processing your fabrication, fabrication is you are assembling all the different components together on a single chip so that they can work together to give you the desired output or result. This is being called as your process engineering and fabrication. Now, problem statement. Let us have a formal definition of problem statement. A problem statement can be a natural language or maybe an ambiguous imprecise. Now, for example, let us consider the case like you visit a client and the client says, see, I have my presence in India, but I want my presence to grow abroad also. Can you help me in this? So, what will be your answer in such cases? Your first question to the client will be, do you have a website? If you don't have your website, then you need to prepare your website so that you can share the URL of your website and you can become global. And this is how you will satisfy the need of that client. The second one is algorithm. Step by step procedure guaranteed to finish. Definiteness, effective computability, and finiteness. Now, let us consider the step-by-step procedure. Okay, you all would be having a Facebook account. Your Facebook account first is your login and then is your password. Now, let us consider the first case where you say that I will just put my login credentials, email ID, and I will log into the Facebook. Is it possible without password? Answer is no. The second case, you say that I'll put the password, I'll not put my login ID, and I will have the access of my Facebook page. Is it possible? Is it possible? It is no. Because both your email ID and password are being interlinked with each other. And without these two synchronizing with each other, you cannot perform a particular task of going to your inbox in case of your Facebook page. Now, what do you understand by program? Express the algorithm using a computer language, a high-level language, a low-level language. Now, you have prepared all the set of instructions, you have prepared the algorithm, you have prepared the flow of the algorithm. Now, the other step is, now comes software. What happens when a software comes? It will read the instructions that have been prepared in the algorithm and it will start coding those instructions. Now, when a program starts, when a programming starts, it is being divided into two tasks. One is front end, and the second one is back end. The back end is the databases. The programming language what you will be using is either VB, .NET, Java, C, C++, Python, and so on. Simultaneously, when you're coding, you need to store those data somewhere. It will be in the form of databases. It can be SQL Server 2018, Oracle, Quellgy, 99, MySQL, and so on, the different databases that have been present. Instruction set architecture, ISA, machine level language specifies the set of instruction that the computer can perform. What are the different data types and the addressing mode? Now, what do you understand by different types of data types? The data types can be in the form of word, it can be in the form it can be in the form of pictures, it can be in the form of Excel sheets, and so on, and the different types of addressing modes that are required for the instructions to be performed. Now, let us understand machine level 1. What do you know by machine level 1? Machine level 1 is being called as microarchitecture. Now, when you say microarchitecture, what is the definition of microarchitecture? Detailed organization of a processor implementation. It gives you the detailed organization. It gives you the detailed organization of a processor implementation, different implementations of a single ISA. Then comes machine level 2, which is called as logic circuits. Now, when you say logic circuit, it contains the basic operations which have been combined together to realize microarchitecture. How the different microarchitecture are coordinating with each other, it is considered in logic circuits and many different ways to implement a single function. For example, addition. Now, when you are performing addition, what are the different components that are required to perform addition? First thing, it requires two numbers, or it may require three numbers, four numbers with the addition sign and equal to at the end. But can you perform the simple task of addition without any binary number getting involved? It is no. So for performing a simple operation of addition, you require numbers in it. Then you have devices, machine level 2, properties of material which are manufactured and which can be manufactured, which can be laid on the VLSI circuit, and then you can combine all of these components together for performance of the particular task.